Welcome to OOTOT, the out-of-the-office investigation from the past into the future of artificial intelligence. This time we're discussing Agentic Design.
Hi, I'm Sue.
And I'm Bob.
And today we are really getting into one of the most exciting frontiers in AI. We're talking about the huge shift from simple models to what you could call true intelligent agents. Using the fantastic framework from Agentic Design patterns, building intelligent systems, we're going to investigate the very architecture of artificial intelligence.
I mean, we're not just talking about systems that spit out answers anymore, Bob. We're talking about systems that can perceive, that can reason, plan, and act completely on their own to achieve some pretty complex goals.
We're going to look at how they're built, how they learn, how they even collaborate with each other, and, most importantly, what this all means for the future of business and technology.
Exactly, Bob. So here's the roadmap for our investigation today. We're calling it the agent's genesis because, well, that's what it is. We'll kick things off by just trying to conceive what an intelligent agent even is. Then we'll get into how to forge its mind using these core operational patterns. From there, we'll see how memory is the key to learning, which turns the agent from just a static tool into something dynamic, something that's always evolving. Then, and this is where it gets really interesting, we'll look at how these agents can collaborate to tackle massive problems. After that, we'll apply all this to real-world business solutions. And finally, we'll take a step back and just consider the future that these intelligent systems are busy building for all of us.
Hi, I'm Sue, and let's jump right into that first crucial step, conceiving the intelligent agent. Bob, I really think we need to draw a sharp line in the sand here. What truly separates an agent from the AI most of us see every day? Like a chatbot that's just programmed to pull an answer from some database. The source material makes this distinction right in the very first chapter, and honestly, it's everything. An agent isn't just sitting there, waiting for you to type the next command. No, it's an active entity. It's perceiving its environment, whether that's digital or physical. It's making its own decisions, and it's taking actions to hit a specific goal. It has intent.
Hi, I'm Bob, and Sue, that is the fundamental difference, isn't it? These four characteristics, they represent a massive leap beyond those simple input-output programs we're used to. Let's really think about what they mean. First, autonomy. This means we don't have to micromanage. You don't tell it, okay, now click this button, then type this exact text. You give it a high-level goal, something like, hey, organize my travel to the conference in Berlin, and it figures out all the little steps itself. Then being goal-driven, that's its North Star. Every single action it takes, every web search, every API call is measured against how much closer it gets to that objective. That's what stops it from just wandering off aimlessly. Then you have adaptive, and this is where the intelligence really starts to shine. It's not just running a fixed script. If a flight is sold out, it doesn't just throw up its hands and fail. No, it learns from that feedback and modifies its plan. It'll look for another airline, or maybe suggest different dates. And finally, proactive. This one is huge. It's not waiting on you. A proactive travel agent might see that your favorite airline just dropped a flash sale, and it takes the initiative to book your flight before you even think to ask. This combination, this is what elevates a system from being a glorified calculator to a genuine collaborator.
Oh, I absolutely love that framing, Bob, from a calculator to a collaborator. So let's investigate how we actually forge that collaborator's mind. Now that we know what an agent is, how on earth do we build one? Well, the source material lays out these foundational design patterns. You can think of them as the agent's basic mental toolkit. First up is prompt chaining. The whole assembly line metaphor is just perfect. You take a big messy problem, like write a market analysis report, and you break it down into a sequence of smaller, specialized prompts. The first prompt generates an outline. The next one fills in the details for each section, a third one pulls out the key findings, and a final one makes it all look pretty. It's like creating a structured workflow for thinking. Then you've got routing. This is like the agent's brilliant dispatcher. An agent might have access to a dozen different skills, and routing looks at a task and says, okay, this part needs last quarter's financial data, that goes to the database tool. This part needs a chart, that goes to the code interpreter tool. It's all about getting the right job to the right specialist in an instant. And my personal favorite, tool use. This is where we give the agent superpowers by plugging it into the real world. It can search the web for live info, run code to do complex math, or talk to APIs to book that flight or hotel. This is what lets the agent break out of its box and actually do things.
And Sue, while those three are absolutely the bedrock, this is where my pragmatic side has to jump in. To handle anything really complex, an agent needs more advanced cognitive tricks up its sleeve. It can't just follow a simple chain of commands. That's where you get into things like reflection, planning, and parallelization. So reflection is the agent's ability to be self-critical. After it drafts that market analysis, it can literally pause and ask itself, wait, is this analysis biased? Did I forget to consider what our main competitor just did? Does my conclusion actually hold up? This is a total game changer for quality. Planning is all about thinking several moves ahead on the chessboard. Instead of just reacting, it creates a detailed, multi-step strategy before it even begins, trying to anticipate roadblocks. And parallelization is all about raw efficiency, breaking a huge research task into 10 smaller subtasks and spinning up 10 versions of itself to tackle them all at once. Without these, an agent is just a very sophisticated puppet. With them, it starts to look like a true strategic problem solver.
A problem solver that evolves, Bob. That's the real key. And that brings us perfectly to our next stage of development, from memory to learning. This is where we go from a system that can simply do things to one that can actually grow. So now we're investigating the concepts that make an agent dynamic, that give it persistence over time, allowing it to get better and smarter with every single interaction. You're listening to OOTO TV with research by author Paul Bulow.
So how does an agent actually grow, Bob? Well, it all starts with these two core ideas, memory management and learning and adaptation. You see, memory is so much more than just remembering the last sentence you typed. It's about building a persistent, ongoing understanding of its tasks, its past actions, its successes, and yeah, even its failures. This is what allows it to genuinely learn from experience and not make the same dumb mistake twice. It's really the key that unlocks the agent's full potential, taking it from a static, forgetful tool to a truly dynamic and stateful collaborator. And Sue, this is exactly where building these things gets incredibly complex, but also incredibly powerful. A dynamic system has to be a robust one. That's why these other practical patterns are just so vital. Exception handling and recovery is non-negotiable. What happens when a website it needs is down or an API spits back an error? A brittle agent just crashes and burns. A robust agent has a plan B, it can retry, it can use a different tool, or it can flag a human for help. Then you have knowledge retrieval, which you'll often hear called RAG, that's for Retrieval Augmented Generation. This is a brilliant pattern that lets the agent pull from a huge, trusted library of outside knowledge, like a company's internal documents or the latest scientific papers, to make sure its answers are factual, current, and grounded in reality, not just hallucinated. But I think the most important pattern on this list, honestly, is the human in the loop. This is our ultimate safety net and our best teaching tool. For really critical decisions, a human is right there to provide oversight, to make corrections, and give that final go-ahead. Remember, we're building collaborators, not unchecked black boxes.
I could not agree more about the human in the loop, Bob. It's absolutely essential for both safety and trust. All right, now things are about to get even more fascinating. So far, we've been talking about a single agent. But what happens when you build an entire team of them? This brings us to agents in collaboration. We're leveling up from a single worker to a whole digital organization. This image is the perfect way to think about it. You have these individual agents, like specialized threads of data, weaving themselves together to solve problems that are just way too complex for any one mind to handle. I mean, just imagine a CEO agent that sets a high-level company goal. It then tasks a research agent to go gather data, a coder agent to build a prototype, and a marketing agent to draft a launch plan, and they're all coordinating and communicating with each other in real time. The potential for complex problem solving here is just mind-boggling.
The potential is staggering, Sue, you're right, but it also opens up a whole Pandora's box of new challenges. And this is the critical question we have to ask ourselves. When you have multiple autonomous agents all running around and interacting, how do you orchestrate the symphony and avoid just a cacophony of noise? How do you stop them from working against each other, or getting stuck in endless chat loops, or wasting money by duplicating work, like two different agents both booking the same non-refundable flight? This is where those more advanced, pragmatic patterns become absolutely non-negotiable. You need sophisticated reasoning techniques to help the agents make complex, logical decisions as a group. And you absolutely must have resource-aware optimization to make sure the whole system runs efficiently without, burning through millions of dollars in compute costs. It's one thing to have a team of brilliant experts. It's a whole other ballgame to get them to work together effectively and economically.
That's a fantastic point, Bob. The orchestration is everything. And this leads us directly into the practical side of all this theory, the agentic business solution. We've investigated the architecture, we've looked at the design patterns, but what does it all mean for the bottom line? Can this technology actually deliver real value today? So let's ask the first mandatory question for our investigation. Is agentic design a successful method for business solutions?
The answer, based on all these principles, is a definitive yes, but it comes with a big condition. And this quote really captures the why. When we talk about improving engagement quality and success, we're not just talking about automating one little task like answering an email. We're talking about creating an entire system that can manage a complex customer journey from the very beginning to the very end. Imagine an agent that onboards a new client, uses the planning pattern to map out a 90-day success plan just for them, uses the proactive pattern to check in on their progress, and spots potential issues before they even become problems. That is a massive leap in the quality of engagement, and it's all powered by the design patterns we've just been talking about. It's really about creating better outcomes, not just faster replies.
Okay, so it can improve quality, I'm with you. But let's get even more specific, Bob. What about growth? Because growth often brings chaos, right? Scaling a human team to maintain that high-quality customer success is incredibly hard, and it's really expensive. So is Agentic Design capable of providing manageable customer success for business growth? Can it actually provide a stable foundation during that messy, chaotic period?
Hi, I'm Sue, and the answer to that is incredibly powerful. This statement frames it perfectly. It's a modality to achieve business continuity while achieving rapid growth. The key phrase here is scalable intelligence. An agentic system doesn't get tired, it doesn't get overwhelmed. It can handle 1,000 customer tickets with the exact same attention to detail as it handles 10, because patterns like parallelization let it scale its own resources on demand. It can onboard clients, manage support, and analyze data 24/7. What this does is provide a stable, intelligent backbone for the company. It allows a business to focus its best human talent on the really complex, creative, strategic problems instead of just getting buried by the sheer volume that comes with success. It lets the business grow without its core processes snapping in half.
And Bob here, and I have to jump in and emphasize this point because it might be the most crucial one in this whole section. These incredible benefits are not automatic. You don't just plug in a single agent and expect magic to happen. The key phrase here is when designed as a complete solution. This means you have to thoughtfully architect the entire system, combining all the patterns we've been talking about. You need the smart routing, the tool use, the memory, the exception handling to make it robust, and the human in the loop for that critical oversight. It is the holistic, well-architected system that delivers these results, not just a bunch of disjointed parts thrown together. A piecemeal approach is a recipe for failure.
That's the perfect way to wrap this section, Bob. It all comes down to execution. As this final quote says, agentic delivery is critical. You can have the best, most beautiful architectural design in the world, a perfect blueprint for an intelligent system, but if the implementation, the actual coding and delivery is flawed, the whole thing will fail. If the tools it uses are unreliable or the memory system is buggy, you don't just get bad results, you can cause real damage. This just hammers home the absolute need for a rigorous, professional engineering discipline. We're not just playing around with experiments anymore. We're building mission-critical business infrastructure. You're listening to OT TV with research by author Paul Bulow. And that leads us, inevitably, to our final and probably most important investigation of the day. We've talked about power, we've talked about capability, and business value. But now we have to ask the big question that's on everyone's mind. Are agentic AI solutions safe and secure? This is where we have to be incredibly clear-eyed and deeply responsible. Building powerful, autonomous systems comes with an immense responsibility to build them safely. The source material, thankfully, dedicates a lot of space to this, with patterns specifically for guardrails, safety, evaluation, and constant monitoring. This stuff can't be an afterthought. It has to be baked into the design from day one.
And this slide, Bob, it just lays out the fundamental tension perfectly. For every incredible promise, there is a matching peril that we have to actively manage. For instance, we get the promise of unbelievable efficiency, but the trade-off is dealing with the immense complexity hiding under the hood. We see the promise of explosive growth, but that's always shadowed by the peril of unpredictability and how an agent might react to a totally new situation. The promise of constant innovation also opens up the door to brand new, unforeseen security vulnerabilities. But for me, the biggest one is autonomy. The very thing that makes these agents so powerful also brings the peril of losing control. The key isn't to be terrified of this peril, but to design for it. And that means building robust safety patterns, constant monitoring, and clear human oversight directly into the architecture from the very beginning.
That's the perfect way to frame it, Sue. And it brings our entire investigation to its ultimate conclusion. We started by just trying to define what an agent is, and we've ended up here, discussing our fundamental relationship with these new kinds of systems. This final thought really summarizes everything we've explored today. We are not just building better, faster tools, we are designing collaborators. These systems are going to be partners in our work, in our research, and in our creativity. So the real pressing question is no longer if these intelligent systems will work. That's becoming a certainty. The urgent question for all of us now is how we will work with them, effectively, safely, and responsibly. And that is the question we really want to leave you with today. Thinking about this future of collaboration is, well, it's both incredibly exciting and a pretty profound responsibility. Thanks so much for joining us on this investigation from OOTO TV. Thank you, Sue, and thank you all for listening. It's a future we're all building together.